finding angles and distance in three-dimensional geometry. So in 3D geometry, if I'm asking you to find the angle between two lines, suppose you can see in the figure here, you want to find out the angle between these two lines over here, that is AB and CD. In 3D geometry, how we will do that? So let's look at that. So here in this plane, you have a line L1, another line L2, which are intersecting. And when they are intersecting, there will be an angle formed, right? Now let's take the direction ratios of L1 as A1, B1, C1 and the direction ratios of L2 as A2, B2 and C2. So I'm taking a point on L1P and another point Q on L2. And there is an angle which is formed here, that is theta. Now how can you find out this angle theta using this direction ratios A1, B1, C1 and A2, B2, C2? So the angle between the two given vectors according to the formula is given as cos theta, which is equal to A1, A2 plus B1, B2 plus C1, C2, the whole divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. And you're taking the whole modulus of it. So this gives us the formula to find out the angle between two lines which are having direction ratios A1, B1, C1 and A2, B2, C2. The direction cosines for L1, suppose if I am putting the direction cosines instead of direction ratios as L1, M1 and N1, and for the line L2 I am putting it as L2, M2 and N2, how can you find out the angle using direction cosines instead of direction ratios? And the formula here is cos theta is equal to modulus of L1, L2 plus M1, M2 plus N1, N2, which gives us the angle between the two lines here. Now, we also know what is the relation between L1, M1 and N1, that is the direction cosine are related using the formula L1 square plus M1 square plus N1 square is equal to 1. Same for the second one also, that is L2 square plus M2 square plus N2 square is equal to 1. Now, what is the angle between two lines in terms of sine theta? Now, we have just discussed in terms of cos theta. What will be in terms of sine theta? We know that sine theta is equal to root of 1 minus cos square theta. And we have found out what is cos theta in the previous slide, right? So, putting that there, you will be getting root of 1 minus A1, A2 plus B1, B2 plus C1, C2, the whole square divided by the root goes in the denominator and we get A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square, right? Yes. Now, doing all the calculations, that is taking the LCM or anything, you get root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1, A2 plus B1, B2 plus C1, C2, the whole square divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. All the other final calculations after doing, we get finally it as A1 B2 minus A2 B1 the whole square plus B1 C2 minus B2 C1 the whole square plus C1 A2 minus C2 A1 the whole square divided by the same denominator as in the previous case. So this gives us what is sine theta, not cos theta, which gives us what? Sine theta. You can even use the formula directly, which is cos theta itself. You don't need to exactly use this formula for sine theta because it's quite lengthy. Now, what will be the condition of two lines when they are perpendicular to each other? We know that when two lines are perpendicular to each other, theta is equal to 90 degree. And when theta is equal to 90 degree, and we know what is cos 90, it is 0. So, cos 90, the angle taken with a cos, like cos of 90 will be 0. Now, so direction ratios, if for the first line I'm taking it as A1, B1, C1 and for the second line I'm taking it as A2, B2, C2, then the condition which says the two lines are perpendicular will be, that is theta is equal to 90 degree or cos 0 or cos 90 is equal to 0, and from that we can also say that A1, A2 plus B1, B2 plus C1, C2 will be equal to 0. That is the product of the sum of direction ratios, that is the sum of the product of direction ratios will be equal to what? 0. So using that condition, if it is satisfied, we can say that the two lines given are perpendicular to each other. Now another condition, when two lines are parallel, what happens when two lines are parallel? When two lines are parallel, theta is equal to either 180 degree or you can even say it is 0 degree. So what is cos 0 degree? We know that it is equal to 1. So here in that case, we can say first of all, the direction ratios of the first line L1, A1, B1, C1 and the second line is A2, B2, C2. And for that theta is equal to 0, we know sine theta is equal to 0 or sine 0 is 0. Now, from that case, we can write it as A1 by A2 should be equal to B1 by B2 should be equal to C1 by C2, which is nothing but when the two lines are parallel, their corresponding direction ratios should be proportional. They can be equal, but for the safer side, we say it as what? Proportional. So that direction ratios should be proportional to each other. A1 by A2 is equal to b1 by b2 is equal to c1 by c2. Now, what is the angle between two lines when equations are given? Suppose they are giving us equations and asking us to find out what is the angle between the two lines. So, if theta is the acute angle between two lines, then for the first line, if the equation in the vector form, it is a1 plus lambda b1. For the second line, it is a2 plus mu b2. We can see that the first line is parallel to which vector? b1. The second line is parallel to the vector b2. So, we know what are the direction ratios of b1 and b2, right? So, if you know that, you can use the formula directly, that is cos theta is equal to modulus of b1 dot b2 the whole divided by modulus of b1 into modulus of b2. So, using that formula, we can find out cos theta and we can easily get the angle theta here in this case. So, that is when two equations, the line equations are given. Now, find the angle between the following pair of lines. The question here is, first one is 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k. That is the first line. And the second line is 7i minus 6k plus mu into I plus 2j plus 2k. So, these are the two lines. I need to find out the angle between these two lines. And to find out the angle between the two lines, we just studied the formula, which is cos theta is equal to modulus of b1 dot b2. We are taking the dot product, dividing it by the modulus of b1 into modulus of b2. That is taking the magnitude of the vectors b1 and b2. So, what we get here is the first line, that is 2i minus 5j plus k plus lambda into 3i minus 2j plus 6k. So, in that case, what is b1? 3i plus 2j plus 6k. So, here a1 is 2i minus 5j plus k and b1 is this one, 3i plus 2j plus 6k. And in the second vectors, what is a here? a2 here, 7i plus 0j minus 6k. There is no j component there. So, I am putting it as 7i plus 0j minus 6k. And what is b2? It will be 1i plus 2j plus 2k. So, we got b1 and b2. Using the formula, which is b1 dot b2, I am taking the dot product. I get 3i plus 2j plus 6k dot 1i plus 2j plus 2k. I'll easily get it as 3 into 1 plus 2 into 2 plus 6 into 2, which is nothing but 19. So, I got the dot product, it as 19. Now, I have to divide this dot product with the magnitude of each of the direction vectors. So, what is the magnitude of b1? Let's find out that. So, the magnitude of b1 will be root of 3 square plus 2 square plus 6 square, which is nothing but 7, doing all the calculations. Now, for the magnitude of b2, it is root of 1 square plus 2 square plus 2 square, which is root of 9, or it is 3. So, I got b1 magnitude and b2's magnitude. Now, using this, I can easily find out the angle between the two lines, that is cos theta is equal to modulus of b1 dot b2, the whole divided by the modulus of b1 into modulus of b2, right? So, using that, I will be getting cos theta is 19 by 7 into 3, which is 19 by 21, or you can say theta is equal to how much? Cos inverse 19 by 21. So, this is how we get the angle between these two given lines. I hope you have understood how to find the angle between two lines when the equations in which form, the vector form, are given. What are skew lines? Lines which are neither intersecting or nor parallel can be called by the name what? Skew lines. So, you can see here there are two parallel lines L1, L2. Here there are skew lines, that is L1, L2 are skew lines. They never intersect or they are not parallel also. And here the third one, we have the intersecting lines. Now, we know that for a parallel line, the distance will always be a constant. That is, the distance between the two lines will always be a constant. And for intersecting lines, the distance is always equal to what? 0, because they intersect each other. Now, what about skew lines? What will be the distance between two skew lines? Let's look at that. What is the shortest distance between two skew lines? So, let L1 and L2 be the two skew lines with equations, and I have here two skew lines which are L1 and L2. Now, what is the shortest distance? We know that the shortest distance is always a line which is perpendicular to it, right? So, I am taking a line which is perpendicular, that is PQ. There is another line which is TS, which is the shortest one, obviously the perpendicular one. So, here PQ is the shortest distance between the lines L1 and L2. Now, what is our objective? It is to find out what is this PQ, right? Now, to find out the shortest distance between the two skew lines, the first line's equation R is equal to A1 plus lambda B1, and the second line's equation R is equal to A2 plus mu B2. If I have that, I can find which is the shortest distance here, PQ. I can find out using the formula, that is unit vector n is equal to B1 cross B2, the whole divided by modulus of B1 cross B2. So, first I need to take this B1 and B2, find out what? The unit vector n, which is B1 cross B2 divided by modulus of B1 cross B2. Then I can say PQ is equal to D dot n, that is the distance dot what? The unit vector n. And using that, I will be getting PQ is equal to ST cos theta, ST cos theta. So here we have cos theta is equal to pq dot st, the whole divided by the modulus of pq into modulus of st. And we can write pq as dn dot, what is st? It is a2 minus a1. And here in the same denominator, we write it as d and st. Now, instead of this, that is, instead of this dn, we can also put it as b1 cross b2. What we are putting it here? b1 cross b2. So we put it as b1 cross b2, the whole dot a2 minus a1, the whole divided by st into b1 cross b2. So that is how we write it here. And find the shortest distance, it will be written that is sd is equal to pq, which is st cos theta. And I can write it as sd is equal to the whole modulus into b1 cross b2 dot a2 minus a1, the whole divided by the modulus of b1 cross b2. So if I have this, I can easily find out the shortest distance between two skew lines. So that is how you find out the shortest distance between two given skew lines L1 and L2, which are having the equations a1 plus lambda b1 and a2 plus mu b2. Put all these b1, b2, a1, a2, you get the shortest distance between the two lines. Now, in Cartesian form, what will be the equation? We know that in Cartesian form, the line equation is x minus x1 by a1 equal to y minus y1 by b1 is equal to z minus z1 by c1. And for L2, it will be x minus x2 by a2 equals y minus y2 by b2 is equal to z minus z2 by c2, right? Now, the shortest distance according to the Cartesian form is a little longer. That is the whole modulus of determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2, the whole divided by the root of b1, c2 minus b2, c1 the whole square, plus c1, a2 minus c2, a1 the whole square, plus a1, b2 minus a2, b1 the whole square. So you can either convert the Cartesian form first into what? A vector form, and usually find out the distance using the previous formula that we have studied, or you can use even this one directly. So anyway, you will be getting what? The shortest distance between two given lines L1 and L2. Now, what will be the distance between two parallel lines? Let L1 and L2 be two parallel lines here with position vectors A1 and A2. So we are having the position vectors as A1 and A2. And I have two vectors which are parallel, that is L1 is parallel to what? L2 here. Now, here if I have to find out the shortest distance, that is PT. PT will be the shortest distance, not this line, because that is longer than which one? The PT here, over here. Now, I am putting this as A1 and here I am putting it as what? The position vector A2. Now, what will be the distance between the two parallel lines? Suppose I am taking the first line's equation as A1 plus lambda B. Here there is no lambda B1. Why there is no lambda B1? Because both of our lines are parallel, right? So I am just taking it as B. And what is the second line? R is equal to A2 plus mu B. That is, again, you can see both the vectors are B over here. There is no B1 or B2 because both the lines are parallel to each other. So we can just put it as what? B itself. So when I put it as B, the shortest distance is nothing but B cross A2 minus A1, the whole divided by the modulus of B. Using this formula, we can easily find out what is the distance between two parallel lines, which is R, A1 plus lambda B, and the second one is A2 plus mu B. Now, what is the shortest distance between the two lines? The first line is I plus 2j plus k plus lambda into I minus j plus k and 2i minus j minus k plus mu into 2i plus j minus 2k. Now, to find out the shortest between the two lines, we use the formula d is equal to b1 cross b2 dot a2 minus a1, the whole divided by b1 cross b2, right? So using that, we can find out what will be b1 cross b2 and what is a2 minus a1. So we have a1 I plus 2j plus k from the equation, and we have b1 I minus j plus k from the same equation. a2 is 2i minus j minus k and b2 is 2i plus j plus 2k. So we have a1, a2, b1 and b2. Now let's find out what is a2 minus a1, which is nothing but I minus 2j minus 2k. And b1 cross b2, by just doing the determinants ij, k, 1 minus 1, 1, 2, 1, 2, we get it as b1 cross b2 is minus 2 minus 1 I minus 2 minus 2 j plus 1 plus 2 k, that is minus 3i plus 3k. So that is b1 cross b2. So we have b1 cross b2 also. Now what will be the modulus of b1 cross b2? It will be root of 3 square plus 3 square, that is root of 18, which is 3 root 2. So we get d is equal to minus 3i plus 3k dot I minus 2j minus 2k, the whole divided by 3 root 2. That is putting b2 cross b1 and a2 minus a1 and dividing that by the modulus, that is 3 root 2. So doing all the final calculations, you get modulus of minus 3 into 1 plus 3 into minus 2 by 3 root 2, which is minus 9 by 3 root 2, the whole modulus. And you finally get the answer as what? Doing all the final calculations, you will be getting the distance as 3 root 2 by So that is how you find out the shortest distance between these two given lines here. So in this session, we have learned about how to find the angle and also the shortest distance to given lines. Now let's summarize this.
Manorama Horizon. Learning made simple.